Okay, cool. All right, everybody, welcome back. So today we're going to start taking a look at how to prepare for the week 2 project, the text adventure. As you've seen in the last few lectures, we've started putting these pieces and parts together to generate our own kind of customized bits of code, our own data containers to track various things. So in this lecture, I'm going to take a bit of a step back, and I'm going to take the day 3 exercise, the farmhouse. It gave you the choice of going back and using the Twine Adventure game that you had created back a few classes ago, and then convert that into C# using the stuff that we had learned. I've received a number of questions on that particular exercise. So to demonstrate the tech direction, the coding direction that we're going to need to employ for the week 2 project, I'm going to take the Twine, the farmhouse Twine, and basically convert that over. So you'll see what kind of was expected for the exercise, and then we'll start to refactor that a bit and start using our classes and be able to then turn that into basically the general concept that you'll need for whichever of the 2 week 2 projects you pick, either the Curiouser and Curiouser or the Desert Escape. Okay, so we'll do a real quick review of the stuff that we talked about last time. I'll give you a quick note on exceptions. I meant to bring this up for the recording towards the end of lecture as we were working on stuff. Every so often we ran into an issue. Well, there's a slight caveat to those exceptions that we ran into that you'll want to be aware of going forward. So I'll briefly mention that both for everyone here in class as well as the guys joining us watching the video, etc. Okay, so last lecture we went through and we looked at if the debugging side of Visual Studio seemed to not respond correctly, we could just really quickly unload and reload the project. That seems to work. We looked at going in and adding breakpoints and being able to attach Visual Studio to Unity, and we could then start running it. And the idea there was we wanted to be able to look at our variables both as they're being set before they've been manipulated in any way, right? Then we can look at them as they're allocated, so we see the space created for them. Then we see them actually being assigned to something. So at any point, instead of having to do some kind of a for loop to dump out the contents of an array, you can just jump into the debugger, pop that variable into either the watch window or jump over to the locals and just expand it and see what's in there. So you can very quickly identify potential problems upcoming or stuff that if you expect it to be in a certain state, right, you can detect for inconsistent states. We also looked at the syntax for arrays just in general, using whatever type it is, popping in the square brackets, and then giving it a name. Additionally, we had to introduce the new keyword to give us some space for these things, and then we could either omit the curly brackets and just pump in a number to give us some specific size that we can then fill out later, or we can omit the number, put the 2 curly brackets back on there, and give it default values going forward. We saw how we could go through and using something like a for loop or just accessing at any point using the square brackets to say which element in this big long array am I actually talking to. We saw that we could both assign something to that value or we could assign a value to that particular element using equals on one side or the other. Those basically were our concepts of get and set. We saw later on that inside our classes, we had a getter and a setter to that class itself, to more specifically the variable that we wanted to mess with. We looked at jumping through the content of one of these arrays, right? Iterating through, taking a look at from any point to any point. By default, we went through and said from the very beginning to the very end, just run through it and take a look. But you could easily go in and set up those square bracket indexers to look at different locations. So you could easily start one counter at the far left, one counter at the far right, and work them back towards each other. Then we further took our data, and instead of dealing with multiple arrays that we would have to synchronize, using maybe one single index or some kind of a I am currently here in all of my different arrays, we said, well, let's just take all the information, the disparate pieces that would otherwise have to be synchronized, and jam those into our own container object. Then we could further have an array of those containers. So at any given time, all you needed to do was access that one single class instance, and all of your data would be inside that. You didn't have to reference multiple arrays to try to synchronize where everything was at. Okay? We also, and I'll show you this here in just a second as we get into the Twine conversion stuff, we also touched a little bit on the idea of public and private, making sure that your variables inside your class were kept secret from everybody else. But our accessors, our properties, were public, so we could call those. That ensured that we had some kind of a gatekeeper, some kind of a bulwark between our data, our variables, and the outside world, so that we could do sanitation checks. We could make sure that all the information was coming back and forth and not set to something we didn't expect, right? So when we look at the Twine example here in just a second, you'll see using these two keywords, public and private, you're seeing private all over the place. It's kind of hidden, it's default, it's how most of our stuff is written. But like you saw in the last lecture, if you delete something like start or update and you manually type it in, it's going to try to give you that private right off the bat. So it's in there, but it's usually just hidden. It's it's shorter code. It's easier to read if it's just not there. But it's worth knowing that it's always private. So if you want to explicitly give access to the outside world, you have to explicitly say, this thing is public. So I'm going to tie that in. You'll see it where, as part of the Twine example, the instructions asked you to go in and say, I want to create a serialized field for my current command, right? The intent there was that you would then be able to see that in the inspector. Well, you can omit the serialized field and replace it with public on the left-hand side of the variable, just to the left of the type, and it'll achieve kind of the same behavior. You'll still be able to see it in the inspector. You'll be able to manipulate it exactly the same way. The only difference here is that if, just like with the class, if this file were talked to from some other file somewhere else in the system, it would now have direct access to that variable that you just made public. You effectively took the lid off. You've made it available to the rest of the world, to the rest of your program. So serialized field is useful if we want to maintain the privacy of our data, but still allow for the editor to be able to manipulate it. In this case, you slap public on there, and it shows it to the entire world. So depending on what you're trying to do, you may want that. You may want some other class out there to be able to take advantage of it, or you may want to keep everything secret and hide it behind stuff like properties. So the note on exceptions that I was referring to a second ago, when I was demonstrating both looking at variables that hadn't been allocated yet, right? I got a null reference exception as soon as I tried to touch like class, for example, the candy class. When I tried to access C, right, before I said C equals new, the computer, the Unity console threw up a null reference exception because I tried to touch something that hadn't been populated yet. So you get the same kind of thing, but it's called an index out of range exception if you start trying to count through using those square brackets to something you haven't created yet, right? We demonstrated an array of size 3, but then I tried to touch the fourth element, which then blew up. So it's worth noting, just generally speaking, as you're developing both in this class and going forward, that you will encounter exceptions. It means those mean that you've or some other system has touched information or tried to touch information that doesn't exist yet, or it's out of range, or it's incorrect in some way. So as a safeguard within this environment, Unity C#, it basically says, okay, you're actively doing something that's incorrect, and therefore I cannot guarantee the rest of the functionality from this point on. What tends to happen is it basically aborts. It's like a return, like we saw with those methods that you can early out and no other code after that gets executed. So in this case, per this example up here, if I had a method called create content and it filled up this ATest array with both the allocation and the variables, if I commented out or didn't actually write this create content method, and I then tried to access test sub-0, this would break. It would throw up an exception, and then these two debug lines below it would never happen. None of the code after an exception gets run because it basically aborts out of the line of code at that point. So scenario 2 is if you've done everything correct and you do in fact have your array being created, but you accidentally go one step further than your array allowed for, what will happen is you'll get that index out of range exception, and just like before, the very next line, in this case trying to access index 1 again, will simply fail. None of that code will be executed. So if you're ever trying to debug something and it's like, why is the code after this point not doing what it's supposed to do? Why is my update giving me tons and tons and tons of, any kind of exceptions? Well, there's a good possibility that somewhere earlier, maybe you tried to set some variable and that set failed. So after that point, any interaction with the system just throws its hands up and says, I can't do this. And so the idea is if you ever encounter any exceptions, stop what you're doing, find out what that is, because it can definitely, just like errors, as we talked about compile errors, that kind of stuff, they can definitely snowball. It can cause the rest of your code to simply behave in erratic, unpredictable ways. So it's always a good thing to stop, figure out what's going on, and then continue your development once you have a clean console. Okay, so to tear into this today's lecture material, we're going to jump over real quick to the Twine project that we have inside the week 1 listing. So if I jump over here to FSO, go down to week 1, sorry, not that one, week 1, scroll all the way down to the bottom and grab this day 3 exercises. So it talked about going through and using commands, a serialized string variable to track this kind of stuff. And then it gave you a link out to this Twine website that you could put stuff into.
I think we used that in another class too. Didn't we use that in
I think like design tools, PMP, something like that. Yep. So the idea is, if you had that project, you could reuse it for this. If you didn't have it, inside this zip was included. Yeah, that's pretty special. Okay, so inside this zip was a couple of files. Let's see here. If you ran the farmhouse Twine file, it's just an HTML file, just seeing it in your browser, you would be able to go through and read some bit of description, and you have options, option A, option B. And if you clicked through these things, you could continue down the path and basically play your own story. You had a back button over here to undo your previous action and maybe try a different path. But eventually, as you continued going through here, you end up with either a win or a lose condition. You've either find the highway, meaning you've escaped, or you've tried to inspect the basement, meaning you clearly never seen a horror movie and have died. So the idea is, if you jump over to the, let's see here. Give me 1 second to sort this out. If you jump over to the, per those instructions, All right, this is all how you would have gone through and actually seen taking this file, going into the import, and dropping it back into the Twine system. Now, taking this file, just maybe single click, double click, whatever, you'll get this node mapping of how this story actually plays out. So the idea is each one of these individual nodes has both a command, like a title, a narrative header, if you will, and then inside, if you double click on any one of these nodes, you'll notice that there are these, for this program, however it's looking at this, it's looking for this as a command and this as a command. So I know that from wake up, I can go one of two different directions. So I also know that I've got this just big block of text as far as my narrative is concerned. So what I'm going to do is take basically a summary of what's going on here. I'm going to basically look at like this node and then where can it go. I'm going to both show you that as far as like how the original Twine was expecting it using a serialized field, and then make the proper conversions to turn this into an actual class. Now, doing this will show you not only how to get away from using a lot of like manual data, the idea of just putting in line after line, very procedural instructions, versus kind of automating the stuff, going out to data encapsulation, using classes, using arrays, and being able to interact with this stuff. Okay, so I'm going to this, like I said, this is all part of your week 1, day 3 stuff. So if you want to go back and take a look at like where this information, where each one of these nodes is actually going, then you're more than welcome to. And then when you play this over here, you can start seeing where each one of these, you enter the farmhouse, blah, 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 and try or inspect. So looking at these things, try the phone, inspect the basement, enter the farmhouse, that's where I'm at right now. And you can just further confirm that by, you enter the farmhouse, find a layer of dust, you enter the farmhouse, find a layer of dust. So nothing really too complex there, but the idea of taking each one of these nodes and then turning it into something useful, that's where it gets a little more interesting. So I'm going to jump back over to, let's see here, jump back over to Unity. Okay. And I'm going to create myself a day 5 project, day 5 scene. Okay, and inside that scene, I want to deal with let's see here, create myself a new script and call this day 5. Okay, create myself a new game object to apply that day 5 script to and actually use it. Now I want to go ahead and Control S to save this scene, drop it in the scenes folder, and call it day 5. Okay, now crack that open in Visual Studio. Okay, looks like it's working so far. I've got the gray, the white, the teal. So let's just give it a debug.log and verify hello world, just to make sure everything is in fact functioning correctly. Okay, so far so good. So the Twine example basically asked you to go through and come up with some kind of an actively tracked command, and then depending on where you were at, just print out something to the console. Now this project, this exercise would have been day 3, so it would have been before classes. You would have known about, at that point, you would have known about if statements and serialized field and strings and debug log, right? So that's basically all it was asking for. So create myself a serialized field, call this thing like, S command. Okay, and down here inside update, we just basically wanted to go through and say if S command was equal to, and this is where we could go back and take a look at the twine nodes themselves. So let's see here. So here we have wake up and a bit of text. Okay, so wake up and then check the car, check the farmhouse. So jumping back over here, if I say that this command equals wake up, then inside my curly brackets here, I could say debug log in this case, I just want to give myself a quick indicator that I'm actually inside this node, because as you start trying to track these things, it can very easily, very quickly get very confusing which node you're in, because the text can loop back on itself in a few of those options. So in this case, I just want to say that I'm in wake up, and I want to do, let's see, what were the commands again? Check the car and check the farmhouse. So check car or check farmhouse. Okay. Now, the idea here is that, like I did with the zombie door adventure game, I want to give some kind of a visual indicator to my player that some button does something in here. Actually, no. So the way the original twine thing worked, you hadn't been exposed to input.getKeyDown yet. So we were using just the string. So the idea was maybe you wanted to indicate like check car was the command or check farmhouse. Like we had, just for example, some more text, right? And then the check car, check command, those were our actual commands. So we needed to be able to put those into our inspector. So I want to give a visual indicator that check car and check farmhouse, those are our actual commands. So I want to wrap this check car right here inside quotes. Well, remember, if I just put a pair of quotes in there, it's going to immediately think, oh, you're ending this string. Well, that's not what I want to do. I want to put that inside quotes inside my printed out string. So it's got to be escaped, right? So we add that backslash right in front of it.
Can I turn those lights off?
Yeah, go for it.
Can you turn the ones behind you on?
Which one?
Behind you. The three on the wall. Yep.
Yeah. Thank you.
Is that good?
And by the way, if the text here is too small, let me, do you want it larger? Little? Yep. Okay. Let's go with, yeah.
Oh, that's way.
All right. Cool. Okay, well, now that I've gone off my screen, I'll finish up this little bit and then drop down. So check car is the command I'm looking for, so I need to end that specific little command block. So backslash double quotes again, we'll put just this little bit inside quotes. Now I'm going to put my cursor here or here, it doesn't matter. Whichever side of that space, doesn't matter, it'll maintain that formatting when I drop down to the next line. And so check farmhouse is the other command. Well, I want to uppercase that C for check farmhouse, and then also put that inside quotes as well. Okay? So at this point, if I save this code and I jump back over to Unity, you're going to see a couple of things. One, that over here on my script, I have this command entry, and it currently doesn't have anything in it. Okay, that's fine. So I'm going to clear this console. I'm going to hit play. And now I get an awful lot of nothing printed to my console. So if I stop playing, take a look at this code, you see I'm doing this inside update. So I'm checking every single frame what command is currently equal to, and I'm specifically looking to make sure that if it equals this wake up, then I want to respond to it. So if I jump back to my Unity, press play, and then over here inside my my serialized command, if I type in what was it, wake up? Well, if I do wake up, you'll notice nothing happens. Because, looking at the code, I have a capital W. Case, spelling, it matters 100% when you're dealing with this kind of stuff, when you're doing comparisons and whatnot. So code, just generally speaking, is very unforgiving with respect to this. So please, if you ever run into something where it's just not responding correctly, just double check that you've written the proper case. A quick way of just sorting this out is to, across the board, just go with lowercase, right? You could actually lowercase the command before you actually use it. Something like this, right? String s test string, or just test, equals s command dot to lower. That'll enforce a lowercase no matter what you're doing. So then I could come through here, and I'm no longer testing the command. I'm actually testing test. So s test. And in this case, if I ran this check, it wouldn't work because test, s test is now lowercase, but this right side comparison still uses an uppercase. So you've got to make sure that both your left and right would match if you were doing that kind of check. So now if I drop this, let me stop running so I don't get any kind of interaction here. So now if I take this W and just drop it down to lower, all right, if I save, jump back to Unity, okay. Now if I run, now if I type wake up, you'll notice that it's actually responding. That's because this string, capital W and all, is taken into Unity, lowercased, and then a lowercase wake up compared to an uppercase, or another lowercase wake up. This if statement becomes true, meaning I then am able to dump this information out. Okay, that's cool, but you're noticing there's a lot of stuff being dumped out to this console. Now I can collapse that, and we see that it's constantly running. So if I stop running, jump back to this little block here, I know that if s command is currently this string, then it's going to print this out. But maybe I only want to see this the one time. So what I can do after that is I can just reset whatever s command is. So s command, just reset it to nothing. That way, when update comes back around, it's going to see s command right here. Try to drop that to lower, but because there's nothing in it, nothing's going to happen. Test, s test right here is going to be that empty string, and then the comparison will happen here. It'll fail, so we only get that printout the one time. So jumping back to Unity, making sure I'm not playing, clear. Now saving this file, and inside Unity, actually let me get rid of that. Okay.
Can you leave on that screen for a second too, just so I can make sure I get everything right?
This one here?
Yeah.
Mm-hmm.
See now where it says wake up, and then it says some text. What is there anything in between that? Because mine isn't all red. Mine isn't all red. The text isn't red.
No, it's just a space. This wake up here inside parentheses was just a visual indicator to me that, like, as I go jumping around through those nodes, I want to be able to see I'm currently in this. So when I punch in either of these two commands, the next command I go to is going to print out like its header as well. So at this point, it's excuse me, it's quote parenthesis wake up parenthesis space some text, and then I have the start of an internal formatting quote, the end of an internal formatting quote. This quote will end this first string because I hit enter, right? So it's going to string concatenate to drop down to the next line. We start one more string, and inside it I say or space start of a new quoted command, check farmhouse, end of a new quoted command, and then I end the string itself. And if you put your cursor on each one of these things, it should highlight blue as far as where the beginning and end is. Same thing for the parentheses here and here. Now, note these two parentheses are part of the debug log. This string, these two pieces that are two strings get squished together and sent to log. But notice inside the sentence, these two parentheses, let's see, if I put my cursor on either side, they're not going to be detected because it doesn't see that as far as like, this is not a call to a method. This is just formatting. Okay, I'll leave this up here for, okay, so 1 second. If I jump back over to Unity, I don't have anything listed. If I play, right, nothing prints, but then if I say wake up, I get it printed one time. Okay, and you'll notice S command up here gets changed back to nothing. So if I then do wake up a second time, I get the printout here. That's because I'm resetting it each time. Okay, so now that I'm done with that, I'll leave this section up so you can keep looking to see if there's something there. But the next little segment after this command wake up actually branches in two different directions. I can either go to check the car or I can check the farmhouse. So after I've done the initial check of test against the wake up, I could then do another test right after that. So in this case, I've printed out the information to the user that they need to type in one of those two commands in order to invoke that particular bit of code. So else if test is equal to check car, okay, and I'll put some stuff in there in just a second. And the other was check the farmhouse. So you're starting to see where this, if I continue to flesh this out, right, I would have a debug log. In this case, it would be for the check car. Actually, let me put that in parentheses, like I said I would do a second ago. Okay, and do something. So in this case, like I believe the example from the twine was that you could, let's see here, if I check the car, I can break the window or alternatively go back to the farmhouse. And you'll notice this arrow connecting these two nodes allows me to wake up and go to the car or wake up and go to the farmhouse. Or from either of these two, I can interact back and forth. Move these around just a little bit so it makes those a little easier to see. So these two nodes can go to each other. But you'll notice pressing something in here, if I break the window, I come down here, and I can alternately go back up and check the farmhouse. Or I can try to find a highway now that I have access to this car. So the idea is, you know, here I would be doing like break the window. Right? So I could continue doing this. I could continue making another if-else check against test being currently equal to check the farmhouse. I could continue sticking all this information in here, and that's basically what the Twine project asked you to do. Go through and give us some kind of a command that we can actively track, and then using your knowledge of resetting variables, change the current value so that it no longer prints stuff out numerous times. In this case, changing S command, you know, and this command to lower thing is actually just, it's a new thing for this class, for the this particular day's worth of lecture. You wouldn't have seen this before, which put greater emphasis on you paying extra close attention to what was being compared in both the left side and right side, making sure that your string, your numbers, whatever it was, actually matched 100%. Now, going forward, generally speaking, you want to make sure, just like we talked about with properties, right, sanitizing the user's input, making sure that it's something we allow. Don't just blindly accept user's input, because it could potentially be something you didn't expect, right? In this case, using the two lower actually gives us a little bit more rules reinforcement, right? I don't care if you typed in lowercase w, uppercase a, lowercase k, uppercase e, uppercase u, for the wake up. I would come through and just squish that down to lowercase across the board. So then my comparisons don't have to be a little bit more involved. I don't have to check for every possible use case. All I do is check against one single lowercase string. And if that matches, cool. Then we can execute whatever the command is that we intended to do. So that's basically what you would be writing to do the entire twine exercise. But we want to take this information, right? This what's going on here, these commands, and how we interacted with this project, and convert it for how we would be using it in our week 2 project. Now, with the week 2 project, instead of using a string, instead of having to manually type out a string, we actually want to respond to individual key presses on the keyboard. So in this case, instead of something like check car, maybe I would have the command be the C button. You press C and it takes you to the check car. For the check farmhouse, maybe I press F. Well, the thing is, if you take a look over here at this listing of nodes, enter the farmhouse, check the farmhouse. Let's see here. There are a few others kind of nestled throughout here as they can kind of go back, right? So breaking the window can take you to check the farmhouse. So the idea is some of these nodes can actually respond to the same letter. So the idea is you want to be able to use your knowledge of if statements, right? Comparing some value against some other value, and also the concept of putting if statements together, both in terms of nesting. So you do one like global conditional that says, can I do this? And then now that I've done this, right, now that I'm inside that state, my nested if statements can do some further rules. So you actually can branch this in like a hierarchical kind of view. You can also start putting these if checks together using the double ampersand, double pipe, the double ors, to be able to say, like, if we've hit a button, maybe we can go one of two directions, but it's only going to go in either of those two directions if we're in certain spots. So we can start to link these kinds of rules together. So just for example, check the farmhouse and enter the farmhouse. If both of these nodes responded to the F key, then inside the code, I would want to say, what's the common denominator here? Well, it's the F key. I can go two different places. So the one single check that I need to look for is, am I pressing F? If I've pressed F, then I can further say, cool, where am I and where do I want to go based on that kind of, those decisions that I've come up with. So I'm going to go through and take these nodes using the knowledge that I have of classes and basically turn this, because the farmhouse is like a Texas Chainsaw Massacre kind of thing. You're playing through a horror game. In this case, think of it like as a horror novel, right? I want to do maybe a create your own adventure kind of book. So to do that, as I build out this project, the example, it's going to have a book motif. So I'm going to create a number of pages. Each one of these nodes is going to represent a single page. The command, wake up, check the car, so on, is going to represent the heading, so the title at the top of the page, the heading, and then the information that's contained in the narrative, the body. It'll be the in this case, I think I call it the body. So it's the actual block of code. It's the narrative, what we're actually going to do. And then we will see in each one of those bits of information printed out to the user, I'll emphasize like this character for check the farmhouse. I'll emphasize the F key can do something. Then we'll start looking at the actual branching, how every one of those buttons can do something, and we can check where we're at and then make a decision from that point. So I'm going to jump back over here to Unity, and I don't need any of this. Give me 1 second. I'm going to pull this back up. So I don't need the serialized field, the S command, start and update as it exists up here. So I'm just going to go ahead and throw comments on here so that you can still reference it should you want to. Okay, but I do still need start, and I still do need update. And I don't need private, so I'm just going to go ahead and get rid of those two. Okay, so now I can put this back to 100%. So I know that I want to take every one of those nodes and turn them into individual pages inside my book. So what I need to do is construct some kind of a container that represents the individual pages. So if I jump back over to Unity, I'm going to do two things. I'm going to take this day 5 file and I'm going to move it inside my day 5, then it's inside my scripts folder. Then I'm also going to right click, create a new C# script, and I'm going to call this page. This is going to represent a single just data container for a page. Okay, and I also want to put that inside my scripts folder. Okay, so double clicking that, reload the project. Okay, this is what I was talking about. The file is listed under miscellaneous. For one reason or another, it didn't detect properly. So I'm going to pull up the Solution Explorer, right click. Also notice that page down here and day 5 is also not being detected properly. So I know also these disclosure triangles next to it to show me more information. They don't exist. So I know that something happened with these two files. So just resolve that, right click on the project, unload. Right click, reload. Cool, everything's back. Okay, so for this page, I know I'm not going to take advantage of any of Unity's given stuff, just like in the lecture, in last lecture. I just want this thing to be a data container. So all I need is public class page. So I'm just going to go ahead and cut that out or copy, whichever, select everything in this file, delete it, and paste my class back in. Okay, put my two curly brackets in there to give my class a body. And now, I said a second ago that I need some kind of a representation for these individual commands and the body. So the title and the narrative, however you want to think about this in your head. As I'm dealing with pages, I have a number of different labels that I could possibly use. In this case, I want to call the top portion here a heading, and the second portion a body. Give me just 1 second. I've got a question here. Yeah, we've actually seen that before. It looks like there might be something either up with this computer or with GoTo Training. Best thing is basically to just ignore it. Sorry. The bar glitch across the top. It's back. Okay, so let's see here. So now that I've got those two bits of information that every one of these pages is going to contain, I need to be able to create a page later on. And so we discussed in last class that I need a constructor to be able to allocate these things and potentially fill them in with stuff. So I know I don't need just a page, just a blank page. I know I'm going to feed information into it. So I know that my constructor needs to have some kind of parameter support. So to be able to be called from the outside world, it's got to be public. And to construct the constructor, it's the name of the class itself, followed by parentheses. And now inside the parentheses is where I'm going to put the parameters for the arguments I'll send it later on. So string to represent the heading and a string to represent the body. Okay, drop down and give the constructor an actual body. And like I said in the last lecture, if I want to maintain this kind of naming convention, then I need to differentiate. Am I talking to the incoming, the parameter names, or the member variables up here? So to do that, I want to talk to this instance of this class dot s heading, and I want to assign it to the incoming s heading. Same thing for the body, so s body equals the incoming s body. Now, for the outside world to interact with this thing, I don't want somebody to come along and basically scribble information into my pages. I don't want them to potentially change my headers. You'll see this kind of stuff is potentially easy to do if you accidentally use like a single quote in your comparisons versus a double quote. Usually the system's going to tell you, hey, I don't think you intended to do this. Sometimes it might be an error, but because of, if you remember back to when I told you about if statements, the content inside it must resolve to being true or false. And it is very possible that you can write code that does an assignment in line inside the if statement that then at the end of the day is true or false. So you just have to be aware of what you're typing in. You want to do an assignment, 1 equals, a comparison, 2 equals. So with regards to the outside world being able to modify this stuff, I don't want them to. That's why I'm going to keep those 2 private variables up there at the top private. Nobody can touch them. But I do want to give public access to this class so that it can be read. You can do getters, right? You can ask it, what is the current heading? What is the current body? So to do that, I'm going to take advantage of a couple of properties. So I could come up here and right-click Quick Actions and then give it, or pick one of these 2 to actually create the property for it automatically. That would give me both the getter and setter that you're seeing right there. But in this case, I don't want that. I just want to, again, for muscle memory, for the sake of practicing, I just want to do this manually. So I need a public string. I'm going to call this heading. And now I need to create the getter, but not the setter. So get another pair of curly brackets for the body, and just say return s heading, semicolon. And now I need to do this exact same line of code, but for the body. So I can take the easy way out. See here, shift and select home, copy that line, drop down once, paste it, and if you notice, if I leave this alone, it a second later starts complaining about, oh, this thing already exists. Oh, that's correct. I don't want to redeclare this particular property. So what I intended to do was say body, and over here inside s heading, I want to change this to s body as well. Okay, so saving this file, and just real quick, jump back to Unity, allow it to do its compile, this spinning circle down here in the bottom right hand corner, just to make sure that Unity sees that everything's okay with this file, just in case I accidentally left off a semicolon somewhere or whatever. Okay, so now back in my code, if I jump over to my day 5, now I already said a second ago that this book consists of an array of pages, just like a real book would. So I need to create page array, and in this case, I'm going to call this array book. Okay. Now, I know that I need to actually fill this thing up with individual pages, and every one of those pages needs to have some kind of information. Taking advantage of that constructor that we just wrote that takes in 2 arguments, now I can go through and effectively clone what we saw a second ago with our Twine example and our farmhouse port, but in this case a little bit more modular, a little bit more containerized. Encapsulated is the word. So in this case, I could just write this method right in place. I could just say book, actually, one quick correction. Instead of book, I want to go a book because it's an array. So I could just write a book equals new and fill in the individual pages. But to just reinforce the concept of methods, I want to go ahead and create a method that's going to do this. The idea here is utility methods. I don't want to necessarily throw all of my functional code just in numerous places and run the risk of possibly duplicating stuff. I want to take out this section is going to allocate and fill. Later on, I'll have one that does a rendering of whatever the information is based on some kind of configuration, some kind of state. So I want to create myself a method. Let's see here. And the idea when dealing with this Unity layout is like start and update, we'll leave those up towards the top. I'll come down here after update, and that's where I'll start writing my stuff. So in this case, I don't want to return anything. And if you follow the concept of book making, the idea here is I want to bind the book, right? Book binders. So now I need to say a book is equal to a new page array, and now I'm going to fill it in with some information. So each one of these pages has to be individually allocated so that we have all of our content. So I need to do new page and then give it some first argument for the header and some second argument for the body, close off the parentheses, and if I want another one, add a comma, which I will want more, but we'll get to that in just a second. And to finish off this array creation, if I go down here to line 48, I need to put a semicolon. So jumping back to the Twine nodes themselves, you'll notice there's a fair amount of text in here. Now, I'm not going to bore you with actually typing this stuff out manually. I will give you a very quick little synopsis of each one of these things, because the part that really matters in this case is not necessarily the busy work. It's making sure that both the heading that we know where we're at and the commands that we know where we can go, that stuff is functional. So what I'm going to do is for every one of these individual nodes, I'm going to take the heading, wake up, and the commands here, check the car and check the farmhouse, and that's the information that I'm going to put into each one of my nodes. Okay, so I've already gone through every one of these nodes myself and pulled out the information that I want to use for this. So if I jump back over to Visual Studio, what I'm going to do is I have established that, let's see here, there's 1, 2, 3, 4, 5, 6, 7, 8 nodes. Okay, so if I copy this line, okay, so selecting it all, Control C, drop down, and paste, 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 paste. I've already lost count. I'll delete the rest of them after I'm done. So these would be blank pages. This page intentionally left blank. So I know the individual nodes are wake up, check car, and I'm omitting some of the words like the, because the shorter your commands are, the quicker the system can actually do the comparison. So break, as in break the window. Highway, as in find a highway. This is actually our win scenario. Check the farmhouse. Okay. Enter the farmhouse. Once I have entered the farmhouse, once I've done that, I can inspect the basement, or I could try out the phone. Okay. Okay, and these pages intentionally left blank. Just get rid of those. I don't need them. So for each one of these individual commands, I just want to go through and, like I said, give myself a real quick heads up that this is where I'm at, and then also the commands that I can go to or from. Now, it's totally up to you, and again, because this is mirroring the stuff that you would write for the Curiouser and Curiouser or the Desert Escape, you basically are tasked with putting in the information, making sure that the commands are proper, and go from there. And just verifying that you can actually play it through. So inside this first one, I know that I'm in wake up, right? That'll be my little header up there at the top. And I want to, for formatting purposes, when I actually see this on screen, I want to just give myself a new line, so as if I hit enter on the keyboard. Now the commands that I can respond to inside wake up are check the car, and in this case I want to give emphasis to C on the car because that's the character that we'll be looking for. Okay. Or check the, and in this case I want to use F for farmhouse. Okay. Now when I'm dealing with checking the car, right, I'm inside check car, give myself a new line, and the commands that I can deal with there are break the window or check the farmhouse. So B, break the window, or check the F, farmhouse. And you'll notice in some of these things that, like I said earlier, the keys duplicate. So F can actually be either check the farmhouse for this node or check the farmhouse for the other node. And actually, just to maintain style here, I want to capitalize this C because I did the same thing here. Capitalize this C and capitalize this W, just to maintain some kind of consistency. Okay, check the car, farmhouse. And my bad, there's not a space between the H and the E, it's the E and the opening square bracket. Okay, so when we write the input handling code, we'll take a look at how F can actually respond depending on if we're in wake up or if we're in the car. Okay, so break, give myself a new line, and if I break the window out of the car, then I can drive the car off to find a highway. Alternatively, I can turn around and go check the farmhouse. Maybe I need the keys for the car, something like that. So I can find emphasize the H, highway, or I can check the farmhouse. Okay, like I said, highway is actually one of our two ending scenarios. You either win or you lose. So if I hit highway, let's go ahead and tell ourselves that we're in the highway, new line, and this is freedom. Okay, so if I check the farmhouse, and again, just as a reminder, these are all listed in those nodes over in that twine file. So if you want to cross-reference what node can go to what node, how these commands are linking to each other, these would be the hyperlinks or the double square bracket on the left and a double square bracket on the right to indicate the twine command. So check the farmhouse. I can give myself a quick heads up, check farmhouse, give myself a new line, and I can, from that check the farmhouse node, I could check the car, or I can go and enter the farmhouse. So I can check the C for car, or enter the F for farmhouse. Okay, now this next line is enter farmhouse. And by the way, if you're writing these and they're going off your screen, you can just as easily come in, put your cursor wherever, and hit enter, and it'll give you that separation to bring it down onto the next line. Just may need to hit tab a couple times to kind of push it over and list it visually. You have that freedom as far as what you're writing, but chances are your screens are actually wider, so you're not dealing with this issue. So let me just bring these other ones down. And for the careful watchers, you notice that I just accidentally deleted a space right before I hit enter. Force of habit, just how I've always done things. And in this case, I actually want to maintain that space between or and check. Otherwise, it's going to be or check as one word. So I want to put my space back in there. See here, highway is perfectly fine. Check the car. So just drop that down. And now I can tab these in. All right, so everything looks, in this case, just a little bit better, so we're not flowing off the edge of the screen. Okay, so I'm dealing with the check farmhouse. Let's just verify, enter the farmhouse. Okay, so the next one, if I'm dealing with enter farmhouse, I'm going to say enter farmhouse is where I'm at. Give myself a new line. And if I'm inside the farmhouse, I can either try out the phone, or I can try to inspect the basement. So try the, and in this case I'll drop down once, P for phone, okay, or inspect the B for basement. Now, if I've not seen a horror movie and I decide to inspect the basement, it's not a really bright thing to do. So in this case, give myself the heads up that I've inspected the basement, or I'm in inspect basement. Drop down a line and say, so never space, because I want never to also have a space between the next word, right? I could have done that on either of those two lines. Formatting comes from inside the string, not outside of it. So, never seen a horror movie before. Okay? You've died. Okay? Alternatively, while you're in the farmhouse, you can try the phone. So, say that we're trying out the phone. Okay, give myself a new line. And when I try the phone, I can go try to find a highway, run out of the house, or I can then turn and try to inspect the basement. So I can find a H for highway, or, and now here I'll add the space before I hit enter. And this is inspect the B for basement. Okay, and visually line those back up. So this block of pages represents the internals of our story. These are all of those twine nodes just written out. And again, I've omitted the actual story core, and you can come through and say, instead of this, parentheses where I'm at and a new line, you could write in your actual story anywhere in here. It's just I needed to emphasize that C is the button I'm going to look for, F is the other button I'm going to look for, so on and so forth. So if I save this, I just want to real quick jump back to Unity, make sure that I'm able to compile. This is by far one of the easiest things to mess up because there are so many commas, so many parentheses, so many curly brackets, that kind of stuff. Okay, so we saw earlier that we had this variable up here at the top, the string s command, for it was the serialized string command, which allowed us, the user, to insert some kind of a string in the inspector. Now, the alternative here, instead of using serialized field, you could put the word public right in front of that. That's what I was alluding to earlier. So that would expose it, and everybody could see it at that point. But I don't need it there, and in this case, for this refactor of the code, I want to go through and actually provide myself the ability to insert some kind of, in this case, I don't want to actually be able to type that command out because I'm not governing where I can go in the story based on the command that I type in. I'm doing story flow and manipulation based on pressing a single key. So input.getKeyDown is what's controlling this. But I do want to see whatever the current story is, wherever I'm currently at, what I'm doing, not just what I see on screen. So what I want to do is give myself both a way to track where I currently am and to see it. So public will allow me to see it. I know it's going to be a string. And let's go ahead and say this is the, let's see here. The way we worked with the twine code up here, that would be like your current location. Okay? So if I do s current heading, right, that could be what I would track. But you remember I went back through and I set the command equal to nothing, right, so that I stopped printing so many extra times. So with this bit of code, I still want to track where I am because I then can do some kind of comparisons, right? I can say where I'm currently at. I can basically make this code a bit more complex. I can govern how I'm able to kind of navigate further in. So I want to go one step further and say, not only do I know where I am, but I want to, when I press any one of these buttons, I want to say, this is where I intend to go. If everything matches up, right, I'm in the proper location and I've pressed a button that's capable of being pressed at that point, then I can say, I intend to go to this other place. My next step is this other place. I can then do some kind of comparison to say, where in my book of pages is this page? Once I've found it, then I can slap that information to my screen. And so to do that, I want to go through and have one more variable. Again, I can make it public so that I can watch this over the inspector. It's also going to be a string, and this is going to be called next heading. This is where I intend to go. Okay. So now, when I start playing this game, the very first thing I need to do is actually have pages inside my book to actually flip through. Right now, I've got an empty book. In fact, I don't even have a book. So I need to both materialize this book out of space and then fill it with all of its information. So bind book was what did all of that logic. So up here inside start, if I call bind book, that's going to take care of creating all that stuff for me. Okay. Now, I also, now that I have a book that I can flip around through, in a second, I'll handle actually being able to jump around to some other page based on, I'm looking through the table of contents, or I'm flipping to, go to page 5 for this particular choice. I can do that here in just a moment with my input to mimic what I was doing with the command, but I need to be able to see that information printed out to my screen. So to do that, I know that this is an array, so I want to do a for loop to look through, to iterate through all the elements and find a match. Now in this case, I know that the one that I want to see on screen first is my next thing. It's where I intend to go. The rationale behind this is that when we very first start playing this game, we are currently nowhere. But we want to be inside wake up. So up here inside the next heading, I can just go ahead and say that my next destination is wake up. Right? That'll prime the system to say, as soon as we start, take a look at where we are and where we should be going and just dump this information to the screen. Okay? Now, just like with my bind book, I want the ability to go through and actually display the story, so render the story to my screen. So if I come down to where I've got bind book, between update and bind book, I want to just do a method that is going to do all this logic for me. The reasoning is I want to call this in a couple of different spots. One, when I very first start playing, I need to get that initial information out there. Now I could go through and say debug log and print out like the very first index in that array, but I might come along later on and decide to manipulate the way my story order is. I might say, if you enter, let's say, a cheat code at the very beginning of the game or something, you can artificially jump to the end. You can go somewhere else in the story. You're not guaranteed to be locked into any specific page. So I want to be able to, when the game starts, have it go to immediately to wherever I've told it, but then as I continue playing the game, pressing the keys, I want to then respond to those commands if that is indeed what the system shakes out to be. You know, if it resolves that this is the proper command, go ahead and do that. So I need a method. I'm just going to call it render story. Okay. And now I'm going to take advantage of one more little new thing. So earlier, when I showed you the dealing with command, and I said that I want to always enforce that my user's input is lowercase. For this particular version of the code, I'm not dealing with user input in that same way. I'm dealing with individual key presses. I know for a fact that that key press is either uppercase, lowercase, doesn't matter in the way I'm going to handle it. But I do know that there's the potential for that string, like when I reset command right here, to be an empty string. I've alluded to it a couple of times up to this point, but if you don't assign equals something, even equals nothing inside those double quotes to a string, that string is not empty. That string is kind of like our classes, how we have to call new to allocate it. It's kind of the same thing. It's in a different state. It's not empty. It's what's called null, meaning it doesn't exist yet. So you can fill it with data, but if you try to interact with it, you know, use it somewhere, it might cause an exception because it's null reference. You've referenced the null variable. So part of the built-in stuff within C#.NET is this, like every one of these things that we've written so far, if you just at the end of it press the period key, press a dot, you'll get a listing of things. Some of that stuff might not be even remotely relevant to what you're doing. Some of it can be. Some of it is additional utilities that sit off to the side. When I did coming off of my string, toLower takes the existing string, shrinks it down, and returns me that value as, you know, an additional string. That's why I captured it here inside my string s_test. Day one, I gave you links out to the C# programming guide and keywords and that kind of stuff. If you go into that document, if you go to that website and take a look at string, go looking through, you'll see there's a whole bunch of constructors, methods, utilities, like all this stuff. And any one of them can do something for you. You don't have to necessarily reinvent the wheel with this stuff. So in this particular case, I needed a lowercase version, so the library already existed. That's why I was able to call it. Well, down here, when I go to actually render my story, there's the possibility that this string that I'm working with, it could have not been set yet. It could be empty. In fact, just like I set s_command to nothing after I had seen it once, I'm going to do the same thing here. I want to go somewhere, but once I'm there, I'm no longer wanting to go there. I'm already there. So I can swap out the values of that current location, that current header, and the next header. I can swap those and say, I'm currently here. I'm not looking to go anywhere else. Well, when I do that, when I, like with s_command, setting it equal to an empty string, I'm going to do the same thing to the next command, which means it could potentially be empty. But because there's always that possibility it could be null as well, I want to take advantage of one more of those extra little bits of functionality, one of those it's already been invented kind of safety checks to say, if my string that I'm looking at right now is either null or empty, then I don't want to do anything with it, right? It's a safety check against two possible scenarios. I could just as easily, let's see here. I could just as easily take that string that I'm talking about, so s next heading. I could put this inside an if statement, and I could say if it's null, right? Null being the blue, being a keyword. I could also, jump in and say, if it's not null or if it is null, and I could chain this using the ampersands or the ors to check against an empty, right? The two double quotes. But in this case, the string library actually gives me a quick bit of code to drop in. So I'm going to take that stuff off the end. I know I want to check, so I am doing an if conditional. But in this case, the method, unlike toLower, which is invoked on the string itself and returned to you, in this case, this method that I want to use actually lives inside the library, not on an instance, not on this S heading, but inside the, see here, on the string itself. Now, this string object, if I put a period next to it, you'll see I get this whole list of all these other things I can potentially do. And in this particular test, I want to see, is this string null or empty? Okay, so string.is null or empty. Now, it's just like log, it's a method, and I need to send it a string to actually do this test against. So I'm going to pass in sNextHeading to do the test on. But the thing is, the way this code is currently written is I would be checking whether or not it is null or empty and then work on a potentially dangerous object. I want to see if I've changed it at some point. So to do that, as you saw with our if statements early, I'm going to wrap this whole thing in an if statement, but I want to check the inverse. I want to invert whatever it's currently going to tell me. So as soon as I push the parenthesis, I'm going to add an exclamation mark to invert whatever the logic was. So if it is not null or if it is not empty, meaning it contains something, then and only then do I want to do any kind of additional checks against this value. So the extra parenthesis at the end to close off the if statement. Drop down a line, add the curly brackets for the if statement's body. Now, what I want to do is, this is the page that I want to go to. So I know I have a book full of pages. I know I want to find a specific page matching, and so that's calling up a for loop, so I can iterate through my individual pages. So for int in page, that'll be my current page that I'm currently inspecting, and I want to start that at 0, but I want to go to the end of my book. So page is less than book.length. Oh, sorry, a book.length. And I want to increase the end page count by 1 every time. So this one for loop is going to just flick, thumb through my entire book rapidly. Now I want to know if this next heading is the current page that I'm looking at. If it is, that's going to be my current location. So if sNextHeading is equal to the books, using the index, the square brackets to index into it, I want to say if this current page in page. Now remember, these pages are classes, so I need to talk to the internals of that class, which is why I have my properties. So I want to know if its heading matches the heading that we're trying to track down. If they do, now I want to do some updates. Number 1, I need to set my current location equal to what we just found. So sCurrentHeading equals sNextHeading. And now I want to stop this for loop from running numerous times because it's predicated by sNextHeading being some value, just like sCommand was, and then I set it equal to nothing. So I want to stop this loop from happening ever again. So sNextHeading equals nothing. That will cause this is string empty. If it is empty, this will return true. That true will become false, and this if will never run. Okay? So now I want to actually see this printed out somehow. So if I drop down, I can do my standard debug log, and I know that this is the current location that I'm at. Okay? So a book in page. So I can copy that, paste it in, but instead of talking to the header, I want to talk to the body. Okay. So now if I save that, yeah. Yep.
So I have a quick question.
Mm-hmm.
The \n for getting it to move down to the next line doesn't work for me. Like it works for the first two, but after like the third or fourth line, it stops doing it and just doesn't read the keyboard volume. You know why that is?
I'm going to pause this. I'm going to pause the recording for. Or do one of you guys want to look at that?
I mean,
oh yeah.
Wait till after class.
Oh, that's fine.
Do that. Okay.
Yeah, there's a handful of possibilities. You might have multiple backslashes together. It might just be logging out weird. We'll take a look at it right after this. Okay, so you guys good with the copying? All right. So now that I've got the ability to print this information out, I need to actually call it. Because at this point, I just constructed it. I've not actually used it. So if I scroll back up, right after I've done my bind book, and again, this kind of goes into the whole exception concept. If I don't bind that book, if I don't materialize it out of the ether, then I won't have something to thumb through, and in which case, because the way I wrote this code, it's actually safe because, let's see here, a book's length will be 0. Even if this next heading is something, as soon as it enters this for loop, this array, it exists, but it's not actually containing anything. So this shouldn't blow up. But if I jump over here to start where I want to see my very first thing printed out to the screen, I can say render story. And now what it should do when the system boots up, because when I start playing rather, because my current heading is currently null, it's not empty, it's null, the next heading is set to wake up, it should create the book. Actually, I want to test that real quick, just as a sanity thing for myself, just in case I've told you wrong. Okay, yeah, I was wrong. So don't do that. See, this is why it's always good to double check, because in your mind you might be thinking it's one thing when it actually isn't. So in this case, a book actually exploded early. So let's see here. Let's see. Attach to Unity. All right, we're now in debugging mode. Start playing. And as soon as it blows up, it's a little interesting. Okay, see right there when I hover over a book and it tells me that the value is null, the very act of this period trying to access a book blows up this for loop, blows up the rest of the program. Nothing after this continues to run. So it's got to be allocated with the new down here at the bottom. If I instead, right, stop running, stop blowing up. In this case, if I instead came through and said, none of this content exists, I would be allocating the book. It would currently have no information. So if I save, jump back to Unity, let it finish compiling, attach, and now play. As soon as my breakpoints hit, because I didn't call it. Live debugging, folks. So back up here with my bind book, if I turn that back on, save, jump to Unity, let it compile, Jump back to Visual Studio, attach, play. Soon as it hits this line, if I hover over, you'll notice a book page sub 0. But if I come over here to, let's say, watch, and I do a book dot length, let's see here, 0. So that for loop will start at 0 and go as long as there are 0, which means it won't actually execute any times. Okay? So just a safety check that if you run into something blowing up in some weird way, you can use Visual Studio to track down what exactly is going on. So now that I'm good with this, I can stop playing. I can recover my actual story. Okay, so the story still exists. I don't need this breakpoint anymore, so I can click on the gutters icon to turn it off. Now that I have my bind story and my bind book and render story, if I save, so just as an example, if I turn off the next heading, right? It currently is nowhere and it's going nowhere. This is actually null. If I jump back to Unity and play, it shouldn't say. Okay, this is also worth noting. Even though I changed that code, right? The default value for the code set up here, it was remembered over here inside the inspector. Now, because I changed, remember a couple of lectures ago, I said you can change this in code. Like here, if I said S next heading equals whatever, this line of code would both overwrite the value that was originally here and the value that was originally here. But the inspector is taking over whatever I've currently got set as my default up here. Now, if you don't want that to happen, right? You intentionally want to change the value, test it to some other scenario. If you jump back to Unity, that cog, that gear icon that you saw earlier, if you click on that, you'll notice there's a number of options. Reset up here at the top is going to reset the individual values that the inspector is currently tracking. So in this case, right now it says wake up. If I do reset, it goes back to nothing. So useful to keep in mind that you can potentially be tripped up by your own defaults in different spots. So in this case, I don't want it to be set to anything. The inspector currently shows that's null, but it's also empty as visualized over here. But if I save this code, jump back to Unity, and run it, this should not print out because I'm currently nowhere and I'm not going anywhere. So that render doesn't actually find a remote target. However, if I step into this S next heading and I instead say wake up, let's see, what was it? Oh, maybe not. Oh, okay. So remember I said that I wanted to call this in 2 locations. One, when I first start, I want to get that initial wherever I'm going. And then as I respond to input, I want to update the story accordingly. That's the second piece of this puzzle. Right here, inside update, I'm not currently doing anything. That's why when I type that information into the inspector, nothing happened. Start, the only place that ever rendered, has long since passed. So just as a demonstration, I'm going to throw in a render story. Okay, save that. We're currently still set to null. And over here inside this value, it's still set to nothing. So as soon as I start playing, we get nothing printed out. But now if I type in wake, and the second I hit P, it automatically understands that that string now has something, regardless of whether or not I pressed a key, which I'm about to do here in a second, write the code for pressing a button to assign a string. In this case, just like the twine example, you would have basically assigned the command. That's the equivalent of what's going on here. So that for loop The if check just before it said this string to the next is no longer empty. It's also no longer null in this case, and now it prints out. And if I click off of that, you'll notice this is actually Unity's inspector. Because I still had it selected, it was retaining my value. But as soon as I clicked off, it reflected that equals an empty quote reset that the for loop actually did. So now over here, like check the car. Now I know over in my code, if I scroll back down, let's see here, check car, right? That's the thing it's looking for. That's the thing it's going to try to match up with. So if I come back up here and I type in check, and in this case I want to do a capital C just to throw it off. Notice as soon as I finished typing car, it didn't update because that's not the matching string. The matching string is a lowercase car. So if I go back a couple of characters and I drop that C to a lowercase, you now see in my inspector the current location is check car, and my console down here updated to wherever it just detected me going. Okay, so that's effectively the Twine example converted to use classes and to use a lot more of this automation stuff. Now we want to go through and actually use input buttons and then also look at where we currently are to determine how we can shift to different locations. So jumping back to my code, right, here inside update, because we're going to be dealing with update ticking every frame. That's why we want to, that's where we want to pull the input and we actually want to respond to it. I need to, number one, get rid of that call to, actually, no. So because I need it for actually displaying this information, I want to put all of my input handling stuff right above this. The idea is render story, even though it has that for loop, even though it's going through all the pages, it's only ever going to do that if I explicitly change whatever the next heading is. So here, I want to go through, and this is specifically for the week 2 project. You're expected to use the input get key down. So I want to go through and say those commands, C for the car, F for the farmhouse, F for enter the farmhouse. I want to go through and look for those specific key codes. So Unity, in addition to all these other libraries that we've got, debug.log and whatnot, we also have the input library. So I can ask input for things like, well, just looking at the list, there's a lot of stuff that I have access to. And in this case, I want to talk to get key, because it's a keyboard key. And like you saw in the zombie door adventure, I have the ability to pull it every single frame. I have the ability to get it once when it's depressed or when it's released. So in this case, I want to deal with get key down because that actually feels more responsive. It's an instantaneous. It's not waiting for me to lift my finger off the key. So get key down is a method just like log off of debug is, and it takes in possibilities. In this case, the variable that I want to start dealing with is this key code. Now, key code dot has all of these various options in it. And it's important that you read the instructions for the week 2 project because it specifically says what keys it's looking for. And if you deviate from that, it's points off if you haven't listed that as part of the, the instructions get changed. So if I'm being told by my instructions that I can press X and pressing X does nothing, that's a problem to the end user because it's a blocking bug, basically. So in this case, I said I wanted to deal with the C for car, right? I'm in wake up and I can either inspect the car or I can do something with the farmhouse. So C is that key that I was looking at. Now I want to do these kinds of choices, these kinds of rules based on if statements, right? These are conditional. I can either go left or I can go right. So I need to wrap this whole line up inside an if. Okay, and give it a curly bracket body at the end. Now, if you're curious why I'm not doing any kind of extra checking at the end, if you mouse over get key down, you'll notice it returns right here in the tooltip a bool. It even says returns a bool during this frame whether or not the particular key code has been identified as being down. So this is basically the same as doing that, just automatic. So I'm going to omit this double equals true. It's just much quicker to write all the rest of the stuff. Now, per the Twine visual that you saw, how those nodes are all interconnected, you saw how those arrows go from one to the next. Some of them can go both ways, others only go one way, and some just end, like the highway or the phone, the highway or the basement, they just end. There is no future state. They're ending conditions. It's either win or lose. In this case, I want to look at where I'm at, and based on, if you press the C key, there might be a couple of different options. I might be able to, for example, check the farm. Well, actually, let's see here. Nope, that's not a thing. Let's see here. Okay, so it's worth noting that as you're looking at these different nodes and how they connect to each other, from, let's say, jump back over here to this node, right? From wake up, if I hit C, I should go over to the car. But if I'm in, let's see here, if I instead pressed F to check out the farmhouse, from the farmhouse I can press C again to now check out the car. So it's worth noting that the C command or the C key can actually respond to these three nodes. So you have to take into consideration where you are at any given moment and where you can go depending on what key was pressed. So if I jump back to my code, if I press C, I know that I can handle wake up, and I can also handle possibly being inside check farmhouse. So I can say if my current heading, which is where I will be right now, if my current heading is equal to either wake up, or if my current heading is the check farmhouse, and note, because I'm scrolling off the screen, I'm actually going to come back over here to the right of the double equals and drop myself down one line just to make this a little bit easier to read. Now, inside the body of that if statement, I can say the next place I want to go is to check the car. Semicolon. Okay? So, if I'm in wake up and I hit C, I want to check out the car. Boom, done. If I'm in wake up and I press F to check out the farmhouse, but then decide, no, I don't want to do that, I want to check out the car, and I hit C again, then I can go directly to check out the car. Okay? We can do the same thing for several of the other keys as well. I talked about the F key, so I want to additionally do a check of F, but only if I've not pressed C just a moment ago. I want to kind of chain these things together. The reason is you can potentially press these keys at the same time, and if it's just an if and then another if right after that, the first if could be true, so you might change. In this case, like if I press C, I might change from wake up to check farmhouse, but if I'm also happen to be at that exact same time, that exact same frame, pressing F, the next check will say, well, if you're checking out the farmhouse, maybe go somewhere else, right? I don't necessarily want that kind of behavior, so I'm going to limit which of these buttons can be pressed at any given time by using the else before I start doing the if. So else, if I'm dealing with input.get key down, key code F. Now here, if I'm currently in the wake up, or, actually let me do it on the line before it, or if I'm currently checking out the car, or if I'm currently checking out brake. Right? I've broken the I've walked up to the car, I've broken out the window, but maybe I decide instead I want to go check out the house or whatever. So I have the ability to make my next location, in this case, instead of Okay, so my next location is to check the farmhouse. But if you cycle back over and take a look at those nodes in the twine or the instructions down at the bottom, you also notice that if I'm currently checking out the farmhouse, pressing F one more time will make me enter the farmhouse. So if the first little block up here has not succeeded, right? I'm not in wake up, I'm not in check car, I'm not dealing with brake, else I could potentially be somewhere else. So else if I'm currently in the check farmhouse, then I need to enter the farmhouse. Now the reason that I did not include this check farmhouse as part of this chain of if I'm here or here or here is because the destination I intend to go to is different. These three send me to check. This one sends me to enter. So I have to break out these two blocks of functionality to independently determine where I want to go based on the if key being pressed. Okay, so now the next key that I can deal with is B for breaking, the window. I also can use it to inspect the basement. So else if input.get key down keycode.b, and here if the current heading, if I'm currently checking out the car, then I know I want to break out the window. So next heading equals brake. However, if I'm not dealing with the car, if I am instead in the house itself, or if you take a look at those nodes, from the phone you could also inspect the basement. So I'm either inside the house or I'm dealing with the phone, I can go into the basement. So else if s current heading is equal to enter farmhouse, or if s current heading is equal to try phone, then I can say that my next destination is the inspect basement. Okay, checking the car, doing the brake, enter the farmhouse, or trying the phone, I can do inspect basement. Cool. So, to interact with the phone, which in this case is going to be the P key, I need to actually be inside the farmhouse. So, else if input.get key down keycode.p, if my current if my current heading is I'm inside the farmhouse, then I can try out the phone. So s next heading equals try phone. Okay? So the final thing that I can look at, if I press the H key, if I've broken out the window of the car, then I can drive the car off. If I'm trying to talk on the phone, then my next step could possibly be to run out of the house screaming, and then find a highway. So else if my input.get key down key code H for highway if my current heading is equal to brake, dealing with the car's window, or if my current heading is equal to me trying out the phone, then my next destination is going to be the highway. Okay. Okay, that was a fair amount of stuff, but if you go looking through, I'm taking a look at where I'm currently at and where I will be going, and just chaining together a series of the if, else if, all governed by, in this case, the common denominator, which is my key press. Now, it is possible, because I see it every so often, to flip this logic around and say, if I'm dealing with the house, then these two key presses can do different things. But you have to be careful there, because you can further mix up the logic. But this happens to be the way I'm going with it, because those key presses are my common denominator, just generally speaking. Okay? So now, if I jump back to Unity, if you need that code here in just a second, I'll switch back over because we're just about done. So now, if I start playing, okay, it currently goes nowhere. So instead of trying to force this to be something, I'm going to stop playing, jump back to my code, scroll all the way back up here to the top, and thus starting the intro state that I want to actually be in is wake up. So I can either undo the comment that I just did and then go into the inspector and hit that reset button. I could additionally drop down here into start and assign that to something. Just going to go ahead and leave that as the default. Okay. Reset here. So now we're in wake up. So if I save, run. Okay. So just following along down here, if I wake up, or when I wake up, I can C to go to the car. I can B, let's see here. Looks like I missed one of the keys. Let's try the farmhouse, see if that one works. No, it doesn't seem to be. So let's take a look at what's going on. Something got overlooked as we went down through this list. Okay, so I know that when I pressed B that did not function. So let's go ahead and put a breakpoint here when I press B. No, but it's tabbed in by 1. That was the issue.
Yeah, because you have to check at the top.
Yeah. So, okay, because we're basically running out of time, the issue, if you notice right here, I'm doing an input, and I have seen this before, so it's a good example of why or how this can happen. When I went to finish off this first if check, I accidentally did not close off with a closing curly bracket down here. So my F check is actually nested inside my if check for the C key. So I would have to press 1 and hope that pressing the other at the exact same frame would be detected in both of those in that flow. To resolve this, just put my cursor down here at the end of all of my logic, at where the bottom of this input for C would be, hit new line, add the closing curly bracket. Okay? Now notice the bind book started complaining. That's because I guarantee that I have shifted this code out of whack. So in this case, if I start scrolling down, just making sure that this input, here's all the heading stuff, there's the end. Cool, that one's good. Same thing here with this next block. If I follow it down to the next line, so 66 down to 76, those look good. I'm just matching each one of these things. Now, if I get down here to the very bottom, I see that I have an orphaned closed curly bracket. So that red squiggly right there is telling me that there's a problem. Also, everything else is starting to go a little haywire. So if I just get rid of that last closing curly, then everything else should start coming back to life. So if I save this, jump back to Unity, okay. Now if I start playing, C to deal with the car, B to break the window, H to deal with the highway. Freedom! Excellent. So now the code flow is actually functioning correctly. Also, you can watch up here as my states are changing as I'm jumping around. So if I stop playing, let's try this another path. So deal with the car, break the window, change directions and go over to the farmhouse. Okay? So I can go back to the car if I want to. And you'll notice, because I have this collapse turned on, the car's number increased by 1. If I had this turned off, I get back to the car. Okay? So now I can just kind of ping pong between the farmhouse and the car, the farmhouse and the car. So that tells you that those two links are functioning properly. So now if I deal with the farmhouse, pressing F one more time is going to cause me to enter the farmhouse. Now that I've entered it, I can try out the phone or I can immediately inspect the basement. Well, let's try to immediately inspect the basement, and I've died. Okay? So that's the other end state. If I stop running, play again, I can go directly to the farmhouse, enter the farmhouse, try out the phone, and from here I can either test out, I can either go to the highway or try the basement. If I try the basement again, I die. Okay, stop running, play one more time, check out the farmhouse, enter the farmhouse, try out the phone, go for the highway, and I win. So I've just verified very quickly. Pressing each one of those keys takes me through each one of those nodes to their proper locations. That's all that's required to verify that these things actually jump around. Now, in next lecture, we'll go in and take a look at getting this console information actually onto the screen. Because right now, like I said earlier, I omitted the actual story stuff. But if I was putting all that extra story stuff and not just where I currently am and where I can go from this location, if I put all that stuff on screen, every one of these printouts would actually go off to the right here and actually, extend behind the scenes. They would have so much more information. And if I wanted to actively read those things, I would have to select every one of these nodes and look at all the information down here. Well, that can get a bit tedious trying to figure out what's going on. So instead of trying to deal with just the console, next lecture, we're going to put an actual text UI object on screen, put this printout, instead of going to debug log, we'll redirect it to the screen so that we can get this nice blob of information up there on screen. And let's see here, what was the other? We'll also go ahead and implement a back button so that we can, at any point, try to jump back one step. Most of this stuff, if you take a look at the Week 2 projects rubric, these things are listed right there in the top required section. So if you go along, follow along with what I just did, but swap out those individual pages and the individual commands that I'm checking, my current location and my next location, change those out for what the Curiouser and Curiouser or Desert Escape nodes actually are, you'll be able to get whatever I think it's like an 80 or 75, 80 on this thing. It's the required section. So that is it for this lecture. I'm going to go ahead and you think of anything? I've got other stuff for the next lecture as well. Okay. Yeah, no problem. All right, so I'm going to stop the recording, address the questions that possibly arose in the chat, as well as questions in here. So we will continue this as well as submission. That'll be part of the probably next lecture as well. All right. Until next time.